Hello everybody, welcome to the Balanced Baseball Run Expectancy app tutorial. I am the creator and I have created this application so that coaches, front office members, and other curious baseball minds can kind of evaluate plays using the run expectancy and run probability. So first of all, in order to access this application, I've uploaded it to my balancedbaseball.shinyapps.io website, and it'll be /run expectancy app. So that link is in the description, or you can go ahead and enter it there. It is designed both for desktop and for mobiles, so feel free to use it on whichever platform you wish. It should work. And the tab that we're going to be focusing on for now is the Evaluate Plays tab. There are other tabs that you can click on your own, and I'll show one after I show this. So let's pretend that you're a coach and you're curious how Major League players sort of did when it came to stealing from first base, because that's a very sort of common situation. Well, you're going to be entering that data from left to right, and eventually we're going to get a decision based on what the application thinks based on run expectancy. First thing we're going to do is check our year, and for here we have data up through 2023 at the moment, so I'm going to go ahead and use that since that's the most complete data set for right now. And then I get to choose the game types, so I can include spring training, any of the postseason, or just regular season. For now, I just want regular season, so I'll leave it at that. And right now we have a runner on first base, and we're just going to say that there are no outs right now. So, that runner's reached on either a single or a walk or a hit by pitch, whatever it is, and they're interested in stealing. Well, next we're going to move to this middle section, or if you're on mobile, you're going to scroll down and you're going to check the play. Well, we want to check what a steal would look like. And then now we've got these other sort of questions that we need to fill out. And our runner on first is going to be advancing to second base, so we're going to go ahead and check that. And then here we're going to be asked for a couple of probabilities. First of all, is there a chance that there's an error? And let's say, well, we're against a pretty good defensive team. I'm going to say that there's a 1% chance of error. Of course, you can drag this all the way up to 100 if you want. And as with the other options, of course, you can check those boxes or select other options if you wish to test it out, which I highly encourage you to do so. But for now, a 1% of an error that sort of advances that batter one more base. So, if they try to steal second base and the catcher throws it over second baseman's head, or the shortstop's head goes into center field, our runner's going to take off for third. And we just need to know that ahead of time, and also just kind of a gut probability. Of course, these probabilities are not going to be something that you can necessarily calculate, but just want to put in a number, a nice fun number to take that placeholder for now. And then the probability that all of our runners steal successfully. Well, right now we only have one runner because there's a runner on first, and let's say that they're a 75% chance to steal. That's pretty good, pretty solid, above average. Stealing 3 out of every 4. That's good enough, and we're going to go ahead and roll with that. And then step 3 here, we're going to evaluate and get our explanation. So we want to evaluate this by run expectancy, and I'll get to run probability in a moment. And then we go ahead and just hit the button, and it will decide. So let's click that button, and our decision, along with some other information, are here. So we've said to go, which means to steal the base, or attempt to steal. Our starting run expectancy is 0.9, meaning starting run expectancy with a runner on first, 0 outs in the year 2023 in the regular season. And the alternative aggregate, or the aggregate alternative run expectancy is 0.93. So there's a little 0.03 increase in that run expectancy, which basically takes all the other possible scenarios in a steal attempt here, and you can get the explanation here where we say, given the bases occupied and outs recorded combination we've entered, it makes sense the runners to go for a steal or attempt to steal. This bases out combination has a starting run expectancy of 0.9. Calling for a steal play could get us into a better position to score with a run expectancy of 1.13. So we're gaining, if we successfully steal, we're basically gaining 0.23 runs by advancing our runner to second with 0 outs. If the catcher is able to throw out the lead runner, we risk reducing our run expectancy down to 0.27. So obviously that's a scenario where wherever it is, our runner makes the out. There's 1 out now and nobody on base. Then in a scenario where the defense surrenders a 1 base error, we could potentially increase run expectancy to 1.46. So that's our runner, like I said, getting to third base on an error or some kind of scenario where our runner is able to advance one extra base, and ultimately where we sort of sum that up, where we have a successful steal probability of 75% and a one base error probability of 1%, our aggregate run expectancy of stealing given these odds is 0.93. And once again, we started with 0.9. So given that 0.93 is higher than 0.9, it's going to be worth it to try and steal in this scenario. Now, of course, you can tinker with that. Let's say we have a runner that we're less confident about. Let's say they have a 20% chance to steal, which is about 1 out of every 5 times. And well, what if we're playing against a, this is a not so good a runner. They're not going to have any chance to make an error. We're absolutely confident. And let's say, hey, we want to see if they should steal with 1 out. We can go ahead and compute that, and we get a different response where the app is telling us to stay because our starting run expectancy is significantly higher than the aggregate of all the alternatives. And you can, once again, read that explanation if you wish. I'm going to go ahead and refresh the page to reset all of the boxes. And now I want to actually show you the run probability tab with sort of a different scenario. Because I've been asking questions about at what point is it worth it to steal, what point is it worth it to bunt, and you can obviously tinker with that with the probabilities that you were to enter. And I'm going to show you that bunting is a little different. So once again, I'm going to leave the year 2023 because I am curious about that. We're going to leave just the 2023 regular season. And let's say that there's a runner on both first and second base. So I'm going to go ahead and check those, and there are 0 outs. Then we're going to choose to bunt this time, and you can see that there are a lot more different spots to enter. Now for our bunts, our runners need to advance 2 bases, and we're going to say on a bunt, our runner on first is advancing to second, and our runner on second is going to advance to third. Obviously, none of them can stay because there's going to be a force at all bases except home in this case. What happens if there's a probability of an error? Well, we're going to say, hey, this team is not quite as good. We think there's a 10% chance of an error. We think that there's a 50% chance of a successful sacrifice bunt. Let's say there's a 5% chance that they pop it up, fail to bunt and no runners advance. And then probability of bunting for a hit, let's say, is also 5%. I'm going to 5%. There we go. Just using some nice numbers for this evaluation, and we're going to go ahead and choose run probability. So you might be familiar with what run expectancy is, but as I compute the decision, run probability is simply altering the run expectancy formula so that we're, instead of looking at the average number of runs scored after any scenario, we're looking at the percentage of times that a team scored during or after that scenario. So for example, with sort of here, we can see runners in first and second with 0 outs. The probability that you're going to be scoring that according to the 2023 regular season, pretty close to 60%, and then just about 2 points higher or so given the alternatives. And so our run expectancy machine is telling us to bunt, and of course you can read this blurb, this explanation, which kind of gives the run probability. Now, there are scenarios where both of these are all going to differ, where we're going to be told something by run expectancy that's different from run probability. The reason that this is going to be different is because with run expectancy, we're looking at the number of runs scored. So whereas with run probability, once we've scored 1 run, we're going to count that as scoring 10 runs in a similar situation. So meaning if we have this first and second base scenario with 0 outs, we can look at the chances of scoring versus the average number of runs scored from this point forward. But I'm going to go ahead and set this to a little bit of an unreasonable number, which is a 100% chance that we have a successful bunt, set the rest of these to 0, and then we're going to compute by run expectancy and see what it says. This is telling us to swing away, meaning to not attempt a bunt, and that's because our run expectancy starts at 1.46 and ends, and the alternatives sort of possibilities, those are have a 1.36 average run expectancy. So obviously there's a small a difference where if we just stay on our first and second base and let that hitter just go after it, that's going to be a much better scenario in this case than having them bunt. But if we make no changes and choose to go by run probability and evaluate, this is actually going to tell us to bunt. And that's because we actually have a 7%, about 6.57% chance to score if we actually advance those runners. So you can see that there's actually a difference in this particular case where we're actually more likely to score a single run if we bunt. However, the average number of runs scored, as if we go back to run expectancy, the average number of runs scored in this scenario actually goes down. So you can actually use this application hopefully to evaluate different scenarios as to the situation. Whether if it's a case where you need exactly one run, then maybe run probability is something that you want to go to. Let's say it's the 9th inning and you know that that one run is going to tie the game and then obviously give you another chance to win it in the bottom of the 9th. Then maybe run probability is what you want to go for. And if you want to try and score as many runs as you can, then run expectancy is something that you're going to want to go for. So the last thing that I want to go over is a View Tables tab. This is going to just pull up all of the tables for each of the years. So once again, you can choose the year. Let's go ahead and change it to 2017. Stick with the regular season. Let's include that postseason because that was a pretty crazy postseason. And we want to view the run expectancy table. We're going to click View Table once we set those. And here you can see for each of those. And you'll be able to match those up to what the application is showing. So if we wanted to look at bases loaded with 0 outs, teams are scoring 2.23 runs or so, and a runner on third with 1 out, that's going to be 0.97 runs on average in those scenarios. If we wanted to look at run probability, we can go ahead and choose that, leave the same settings, click View Table, we get the run probability table, and then now we're going to read these as percentages. So in the same sort of scenario, bases loaded and 0 out, I know how frustrating it is to have that and not score. Well, it turns out that in 2017, about 17.5% of the time teams did not score with the bases loaded and 1 out. Whereas with the runner on third, about 65% of the time they would score with a runner on third and 1 out. So hopefully that shows you how to use the application. Feel free to play around with it and evaluate all kinds of plays within the limits of what the application allows. Of course, I'm happy to take some feedback. Feel free to leave it in the comment section below or not. And then, of course, you can take a look at the other tabs as I update them. There may be some new stuff from after this tutorial that you can take a look at. But feel free to use it. Again, have some fun. Let me know what you think. And thank you very much for using this application.